All right, welcome back. So we are on 2.3. We're talking about 0 as an exponent. And maybe a treat for you if you're into this sort of thing, this is going to be a short lesson today. So if you're doing one lesson per day, then good news for you, that's going to be a short day for you. So again, we're talking about 0 as an exponent. And we've seen a problem like this before, I think in multiplication back in chapter 1, where we try to find the pattern and see if we can find out what the blank is going to be based on that pattern. So go ahead and do that, see if you can recognize a pattern here, and then fill in this blank. All right, so you might have seen that this pattern, as we go down, is going to be dividing by 2 or cutting in half, however you want to think of that. Same thing though. So 16 divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. And the reason why that's the case is you remember what exponents are, is just repeated multiplication. So if we take the example of this 2 to the 4th, that's the same thing as saying 2 times 2 times 2 times 2. And this next one will be 2 to the 3rd, which would be 2 times 2 times 2. Well, 2 to the 3rd we know is 2 times 2 is 4, times 2 is 8. And now if you times 2 again, it's going to double it, right? It's going to double it to 16. So going the other way, if we take away one of the 2's, it cuts it in half or divides by 2. And it's going to keep on happening as we go down. All right, so following this pattern, so go 16 to 8 to 4 to 2, dividing by 2. So then what would be the fill in the blank right here would be 1, because 2 divided by 2 would be 1. So that might not be super obvious when you raise a number to the 0 power that it would be 1. You might not think that, but that is indeed what it is. So I'll show another reason why it might be a little bit more clear as to why raising something to the 0 power is going to be 1. So here's another example. So we found out in the last lesson that if we divide two exponents with the same base, then we can subtract them. So 2 to the m divided by 2 to the n is going to be equal to 2 to the m minus n. We can do it both ways. So if we had, let's say, 4 to the 4th divided by 4 to the 4 squared, let's say, that would be equal to 4 minus 2, which would be equal to 4 squared. Because we can subtract the exponents if we're doing division. So we can go the other way too. So if we have a number 8 to the, say, 3 minus 1, we could convert that if we wanted to 8 to the 3rd divided by 8, something like that, or 8 to the 1. All right, so now if you remember that, now try to pick values for m and n that would end up subtracting to be 0. So make m and n the same number, and then what would happen? Go give that a shot and see what you think might happen. All right, so if we do that, let's go ahead and set both m and n equal to 2. So using this formula right here, let's do 2. And then if we set both m and n to 2, so it'll be 2 to the 2 minus 2. And we know that's going to equal 0. Let's go ahead and first convert it to division. That's going to be equal to 2 to the 2 divided by 2 to the 2. And that, of course, is going to be 4 divided by 4, which, of course, is going to be 1. So once again, we find out that what was going to become 2 to the 0 ends up ultimately becoming 1. And really, that works with everything. So a to the 0, so anything we raise to the 0 power is going to be 1. Oh, also there's a video right here, and I recommend, as always, to go and check out that video for more explanation. All right, so now let's jump into this problem right here. This is very simple. Now that we know that raising to the 0 power is 1, you should pretty easily be able to solve this one. So go ahead and give that one a shot. All right, there's really no trick to this one. So 6 to the 0 is going to be 1. 6 to the 1 is going to be 6. 6 squared is 36. add them all up, and you get 43. All right, so this next one, let a be any number, simplify this right here. And it actually doesn't even matter what a is. I would recommend you practice with things like this, practice actually not making like a dummy number for a. Get comfortable with keeping variables in the equation for longer than you're used to. You might want to come up with some sort of example. Let's say a is equal to 3, and then go ahead and solve it when a is 3. And sometimes it's easier to do that, and sometimes it's helpful to do that. But in this case, you can go ahead and do it without ever coming up with any example for a. So give that a shot for this one. All right, well, if you notice, we have this equation right here. We have 4a to the 0 and then 4a in parentheses to the 0. Well, we know we do exponents first, or if we do parentheses first, but we can't simplify this anymore. And then we do exponents. So a to the 0 is going to be 1. So we have 4 times, and now this is going to be 1, and then times, and this all is going to be 1. So we have 4 times 1 times 1 is just going to be 4. So again, we didn't need to put in any value for a because it ends up being canceled out and made 1 anyways. Okay, and then the last one. We're on the last problem already. So this one looks really scary. And it's going to take you a little bit of time to work through this one, but I do recommend you do pause the video here and give this one a shot because it's kind of a neat problem once you go through it and get to the end. So give this one a shot and see if you can come up with the answer. It's simpler than it looks. All right, so what we're going to do here is, let me just write it out here. So here's the equation that we're trying to solve right here. Trying to get the value of this here. So let's go ahead and write it out. So we have 2 plus 3 plus 4 plus 7 all raised to p plus q. Well, p is this here. So that is 2 minus 3 minus 4 plus 7. And that's raised to 2,347. 2, 3, 4, 7. All right? And that's going to be plus p plus q plus negative 2 plus 3 plus 4 minus 7 to the 2,347th. All right, that looks like quite the equation here, but we have some parentheses here. Let's go ahead and do our parentheses first. That's what we're supposed to do here. 2 plus 3 plus 4, let's see, that's 5, 9, 16. So we have 16 here. To the, let's see, we have 2, well, let's see, we have a positive 7 here. We have negative 3 and negative 4, so that's going to be negative 7 there. So 7 and negative 7, that's going to be 0, and we're left with 2. This could be 2 to the 2,347. 2, 3, 4, 7. And plus, let's see what we have here. All right, so we've got a negative 7, and we have 3 and a 4, so that's going to be positive 7. So that's going to cancel out. We'll be left with here, negative 2. And you probably see where this is going now. Negative 2 to the 2, 3, 4, 7. Well, what's 2 to the something minus 2 to the something? Because remember, adding and negation is the same thing as subtraction. So 2 minus 2 is going to be 0. So that's going to be equal to 16 to the 0, which is going to equal 1. So hopefully you're able to come up with that one. I know this one is a little bit more work, and it certainly looks a little bit more scary, but ultimately just comes out to 1 once you realize that these two exponents just subtract down to 0. And that is the last one. So go ahead and do your 2.3 exercises, and we'll see you tomorrow.